This is video on statics of coplanar non-concurrent forces. This is 8th video in the series, and here we are going to look at how to solve truss by using method of sections. In method of section there are going to be 2 videos, so this is the first video. Okay, now something about method of sections. In this method, you are required to directly find the force in a member of the truss without solving the truss fully. See, there are occasions when you are just interested in any one member force of the truss. You don't want forces in other members. So that is the time method of sections course. Now the method consists of cutting the truss in 2 separate parts, and for cutting the truss, following guidelines are useful. First guideline is member of interest must be cut. Means whichever member force I want, that member I have to cut. Then truss must be cut in 2 separate parts, and one of the parts then is considered for equilibrium calculations. Now, as far as possible, we cut only 3 members and try to use sigma m equal to 0, failing which, that is, if usage of sigma m equal to 0 is not possible, then we use sigma fx equal to 0 or sigma fy equal to 0. These A, B, C, D, E points, 5 points, will be demonstrated in the problems which is starting from the next slide. Now, suppose if truss geometry is such that you are not required to cut more than 3 members, then you have to use only m equal to 0. Now this type is covered in video 2 on the method of sections. Okay, so this part won't be covered in this video. Okay, now here is a truss, and suppose I just want force in member BC. That's all. Now the first method about finding the reaction, support reaction, is same as method of joints. Though you see geometry will be known to you. For you replace the supports by appropriate reactions and do sigma fx0, sigma fy0, sigma m0 for the entire truss. And if you do that, as we have done in previous videos, you will be able to work out the reactions like this. Okay, so that we have done it fast, because here our main interest is to explain the method of sections in particular. Okay, so we are ready to actually start with method of sections. Now suppose I want force in member BC. So let's remember those steps. Member of interest must be cut and truss must be cut in 2 separate parts. So I have to cut member BC. So look at this cut. I have cut it, and I have taken the cut across so that truss must be cut in 2 separate parts. Now one of the parts only, it's the left part, I am going to take for equilibrium, and I have called out these 3 forces. I am interested only in F1. Now look at this argument. This part of the truss, when it was inside the truss, it was in equilibrium. Now we have cut it, but we are exposed F1, F2, F3 as external forces to this section, and therefore under the influence of F1, F2, F3, external loads at B20, at F20, and these reactions, under these, this entire truss continues to be in equilibrium, and therefore we can use sigma fx0, sigma fy0, sigma m0. Now 3 equations are available to me, but little intelligently I use sigma m equal to 0. Then what happens is F2 and F3, in which I am not interested, but they have become external, but I am not interested. See, they pass through E, and therefore if I take moment about E, F2, F3 don't appear in the equation, and what I get is 36.67, the reaction into 6, clockwise, so negative, 20 into 3, plus 20 into 3. See, both are anti-clockwise. And then F1 into this height 4. that is clockwise negative. Okay, now so you see this equation only has one unknown f1 and we can work out, and it has come negative. Now here I have taken assumed direction away from tension, away from the section, that is tension. It's come negative, so all I can say is f1 is 25 compressive. Now see the power. You have managed to work out in one section and one equation the required force without solving the entire Truss. That's the power of method of section. Now suppose I was never interested in F1, but I was really interested in F3. Then we could have taken the same section, but as you can see, in this my new situation, F3 is of interest, F2 and F1 are not. F1 and F2 pass through B. So if I take moment about B equal to 0, F1, F2 won't appear, and I will get F3 straight away. See, it will be 36.67 into 3. See, I am taking about B and is clockwise, plus F3 into 4 anti-clockwise equal to 0, and I get my F3 straight away. Now suppose I was never interested in F1 and F3, but I wanted only F2. I could have taken the same section, and instead of then I look for F1, F3, whether they meet somewhere. They don't because they are parallel. Then I go for sigma Fy equal to 0. What happens? F1 and F3 happen to be next direction. So sigma Fy equal to 0, they will not appear. What will appear? Minus 20, and F2 sine 53.13, that's the angle, and plus 36.67. So see, in single equation you have got F2, and it has come negative, so fine, it is compressive. But see the power, so the method of so you have taken the right section, use the right equation, and managed to do it in one step. That's the method of section. Now suppose I was interested in these forces, force in member AB, force in member FE, and force in member BF independently, one by one. So what I would do, I would use the same thing. I'll take member of interest and I'll see that it is cut, and then that cut truss must be cut in two separate parts, and see this cut. Now I use the lower part of the truss. I call this F4, F5, F3. Alright. Now if I wanted F3, then I would take sigma MB equal to 0, that moment about B equal to 0. What I will get? See, F4, F5, in which I am not interested, they are passing through B. So I'll get my F3 in single equation, 36.67 into 3 clockwise plus F3 into 4 anti-clockwise. This height is 4, and I get my F3. Perfect. Suppose I wanted F5. Then I look at F4 and F3. They pass through A. So I take moment about A. I get in a single equation. What is that equal? 20 into 3 and F5 into 3. So F5 itself comes out 20. Great. And suppose I was interested not in F3 and F5 but only F4. Then I would only do a small construction, that is drop a perpendicular from F on F4, and then take moment about that point. You see, I take a moment about F. Now what happens? F1 and F3 are passing through it. So I straight away get F4 into the perpendicular distance, which is 3 sine 53.13, minus 36.67 into 3, and that is equal to 0, and I get my F4. So see, this is method of section. Take the right section, use the right equation, and get the answer in one single step. That is method of section. Thank you.